I'm not sure whether this is a welcome back, dear friends, because the video is so long and I'm losing the plot with all the editing. But welcome back, dear friends. Anyway, it's time to think about writing the functions to actually tell the hour time properly and the minute time. So far, we have this, if you remember. If I switch it on, and it's not even connected to the computer, but because the USB power supply is supplying all the power, the Arduino is programmed and it knows what to do. So it's going to go back to the two datum points. So the first thing to do is to find out how many steps between the numbers there actually are. Because if you do a search on the BY whatever it is stepper motor, you will find all sorts of different people saying all sorts of different steps per rotation. The best way to do it, honestly, is via experimentation. I've got to say, but the stepper library and the RTC library are still at the top of the sketch. So here's what we have. We have the setup with the pin mode set, and there's a sort of aid memoir to what we've got connected. Then we call the calibrate hour steppers, which moves the hour pointer back to 12. That's our datum point. Same thing with the minute stepper, that moves it up to the top. And what we're going to add now, for test purposes, is our stepper enable outputs so that the sketch can switch the motor coils on and off. Our stepper run to new position. That's very handy, Harry, because that means you don't have to keep calling a run command, stepper run somewhere. It just does it. It blocks any other code from running while it's doing it, but we don't care because we can wait. Then our stepper disable output, so it stops any of the outputs from remaining on the coils until you next tell it to enable. I've guessed at about 230 revolutions for it to go from 12 to 11. So let's upload that and try it. The loop, by the way, is just empty. There's nothing in it. We're just doing all this in setup. So I will upload that. Having first remembered to plug that back into the computer so I can upload it. Obviously having switched the USB power supply on first. So it's now uploading. Let's see, what I hope is going to happen is it's going to reset itself, calibrate itself to 12 and then move to 11. This is the calibration bit. And then hopefully, oh yeah, and there's the minute hand calibration, that's right. Ooh, oh, Cantona, that's amazing. Actually, I don't think it's that amazing because I spent yesterday, Sunday, writing this code to make sure, well, to give the impression that I know what I'm talking about, and I think I start off with all different numbers. Try it around, what did I say it was, 2:30. Add a little bit and keep trying it, keep uploading it until you've got it right. Because the next thing to do is to look for additive errors or whatever they're called. So we want to multiply that by 11 in the vague hope that it'll start there and then go 1, 2, 3, 4, 5, 6 all the way around to 1. Let's give that a go. So that comes out to be 2530. We'll upload that and see where that goes. Oh, that's not too bad. It's a little bit too far though. So I'm trying it again with 2490 instead, so 10 less. And I've just commented out the last figure just as a reference, so I sort of get an idea of vaguely what's going on. Right, so we've uploaded it. Let's see where it's going to go this time. The higher the number, the further round it goes. Well, that's not quite far enough, so a little bit more. But you can see what fun this is and how actually it'll only take sort of 3 or 4 goes to get it absolutely spot on. So now what we need to do is to write our very own function to set that pointer to actually show the current hour. We're not going to worry about the current hour actually is yet. We're just going to write a little test thing so we can quickly cycle through all the different hours rather than having to sit here for 12 hours just to check. Yes. So we've commented out the test thing that we were using. Here's the loop that's empty. And then we're going to create our function. This time we're going to send it an argument though. So it's void because we're not returning anything. Display hour, seemed like a nice name. Integer called hour int. And that'll be handy because when we call it we can just send it, tell it, okay, it's 6 o'clock. So we'll put a 6, send it display hour 6. It then knows what to do. Now we need to start thinking about the logic. What we're going to do, we're going to send it a number between 1 and 12. We need to sort out what to point to. And here's one I prepared yesterday. And by the way, all the other functions that we've written so far, you just move them down the sketch, and they're still there and they can still be used, but they don't get in the way. So let's have a look at this then. First thing we've got is an if statement. If our int, so that's our int from there, a number between 1 and 23 is greater than 12, because we've only got 12 numbers, then our int equals our int minus 12. Then we move on. If our int equals 12, and this is important because if it is equal to 12, we don't want it to calculate its movement, we want it to go and calibrate. So this says, okay, if the current position is not equal to 0, e.g. it's not on the 0 that we set when we calibrate it each time, then calibrate our stepper, because this function is being called over and over and over from within the loop. And if it didn't have that, it would go round and round and round. Oh, it's equal to 12. Let's calibrate the hour stepper. Oh, it's equal to 12. Let's go backwards and forwards, and your clock hand would just be going backwards and forwards for a whole hour. So that's silly. This is something new as well, because we're now calling another function from within this function. And that function, if you remember, calibrates our stepper, is here. And it does everything we want, basically. You can look back at it and, yep, that's absolutely fine. It moves it till the switch, then sets the current position to 0, so it recalibrates it each time and then disabled outputs. So rather than writing all that again, which you could do if you wanted to, just call it. Call your lovely function. If else. That means that if this isn't true, then do this without any other ifs. That means, in effect, with this function, the number is going to be between 1 and 11. So that's fine. So if it's between 1 and 11, now we can do some calculations. We worked out in the end that the number of steps between each of the digits was 226, because once we got it going all the way over and found it was 2,500, whatever it was, we just divided that by 11, and it gives us a better idea. So a little simple bit of maths, another integer, hour steps, new variable, equals 12, take away our integer, times 226. 12 take away that means basically the further away the number is, the further it goes. So if it's got to go to 1, that's actually going to be 11 separate steps. Once you've calculated that, that's times 226, which is the distance that we worked at in steps. And then we go to the same old thing, our stepper enable outputs, run to new position, our steps, disable outputs. So that should work. Hopefully that makes sense. Thing is, as I mentioned previously, we don't want to have to sit here, even though it's very pleasant, and wait for 12 hours to see whether the pointer does move to the right place. So we're going to use a for loop to send our new display hour function a number between 1 and 12, just one after another, to check whether it works. So in the loop part of the sketch, we're going to create a for loop, which says for integer I, that's the normal way to do it, equals 1, semicolon, while I is smaller or equal to 12, semicolon, each time it goes round, add 1. So it's going to go round and round and round, sending our lovely display hour function the value I between 1 and 12. And then after each time it's gone round, it's going to delay 3000, which is 3 seconds, because it's in milliseconds. So we're going to check whether it's gone to the right place. Once it's gone round 12 times, because it's in the loop, it'll go back again. But that's lovely. So let's give that a go. So let's upload that. So it's going to recalibrate itself. Right. Now what's going to happen? It should go to 1. It's slowing down. That's not too shabby. Not quite 1. What about 2? That's spot on. 3, lovely. So that's a lovely way to check whether your calculations are right. One thing, these little stepper motors I've found tend to be a bit sticky if you first start using them, so they don't sometimes necessarily go far enough. So it's a good idea just to leave a sketch like this running whilst you go make a nice cup of coffee or tea, whatever your preference is, and then it seems to loosen up and actually become a little bit more accurate. But it seems to be working. And it went, when it was 12, it went over and clicked rather than calculating it, so that's nice. And now it's just cycling around again. So leave that going a little bit. Happy with that though. So that's the calculation version. Now with some of the clocks that I've made, I've found that I can't get it to calculate properly. No matter what I do, it might be the weight of the hand suddenly slopping over, because there is a little bit of slop with these motors, or I have no idea. But when I can't get the maths to work, I then use an array of values. So you don't have to do it this way. This is an alternative way which may be of use to you. Here is the existing display hour function. With everything else is exactly the same, except where you get to the place where you want to display a number between 1 and 11. That's what we originally had. Integer hour steps equals 12 take away hour integer times 226. So if that didn't work, we can use this method. Now, I have used this method many times when I can't get the other one to work. You create an array in which to store the number of steps per number, which is very handy because then you can tweak them. This is what I started out with yesterday. This is where I just calculated, look, 226 times 2 times 3 times 4, like that. So it mimicked what we had with this mathematical calculation. And then I tried it, and where it was off a little bit, I changed the number, added some here, deducted some from other ones. Most of these are actually fine this side, but I just fiddled with a little bit. The way it works is an array is a collection of information in particular positions that you can look at. So this is how you set up an array with these square brackets. It's an array of integers, and in curly brackets you then tell it all the different values you want to be stored. You can have as many as you want. So we've stored them. If we look in position 0 on the array, it reads that. Position 1, 2, 3, 4, so on and so forth. I've added that because we want to give it a number between 1 and 11. So it's never going to see position 0. So we're just going to put a filler in there, if you like. So if our int is 1, it's going to read that value in 1. If it's 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, we don't need a 12 because that's taken care of up here. And then what it does, this is the same other than our stepper run to new position, our steps, so it's going to look in this array in position our int, which is the hour that we've sent it. So it's just going to look that up and move that number of steps. Isn't that handy? So as I say, I started with this one and then had to fiddle and tweak. I'll upload this and let's see what it does. So it's uploaded, it's resetting, it's calibrating itself. So now let's have a look. You see, just adding a few. And I also added a, and you know, you fiddle and fart around for a little bit, but it doesn't take long because you quickly get a feel for you know, how far a number of steps equates to in real life. So that's lovely. So in effect, we can now tell the time with the hour hand. So to recap, you can use an array of step values to display the hour, or you can calculate the hours mathematically if you know the number of steps between each, and it's pretty accurate. Just trial and error, really. So now we've got the hour hand sorted out, let's have a look at the minute hand. Everything's exactly the same, except now in minute stepper enable outputs, minute stepper run to new position, minute stepper disable outputs. And what we want to do is to try and guess how many steps it is for a full revolution of the motor. Here's some I tried yesterday. And despite the motors looking the same and having the same number on, as I say, they regularly vary. So you can't assume anything. I started with 4080 because I looked at the clock face and thought, well, that's how many steps there are that far. So I'm going to guess, oh, that's right the way round, so that's, yeah, let's give it a go. Thankfully, if you get it wrong, it can't crash into anything. It's just going round and round. So I thought it was 480 and then 488, 490 and 493. It ended up as being 4,095 steps. Don't you start with that by all means if you want to try this, but don't assume it will be. So let's upload this and see what it does. So the minute hand is calibrating. It's going back to the read switch. It's nice. Now what we want is for this to go all the way around, one revolution, and to end up back where it started ideally. That's the goal. Lovely the way it slows down. Look at that, that's spot on. But like I said, that did take a little experimentation. So now, just as we did with the hour hand, we want to create a function to move the minute hand between 0 and 59. And I've divided that by 60. And handily, it's come up with a whole number, an integer, 68 steps per minute then. Now we're ready to start writing the function. So the first thing is to write the display minute function. It's very, very similar to the display hour one. We void because we're not returning any information. We've called it display minute and we're sending it an argument, an integer, called min_int for minute integer. Thank you. Then, first thing it does is to see whether min_int, the current minute, is equal to 0. By the way, I should have probably mentioned this a lot earlier. If you have one equal sign, it means make something equal to something else. If you have two equal signs, then it's a sort of logic comparator type thing. So that will compare those two values, and if they're equal, then do what's in the brackets. Then, as before, we want to check whether the minute pointer is actually on 0. Because we don't want it, because this is cycling round and round, we don't want it to keep going that. Is it 0? Yes. Okay, let's calibrate minute center. Is it 0? Yeah, etc, etc. So if it is at 0, that's fine. It just leaves this function, finishes it. But if it is asked to be at 0 and isn't at 0, then it runs our lovely little calibrate minute stepper function that we wrote the other day, and then leaves the function. If, however, it's not equal to 0, it moves on to this part. And in this part, as before with the hour one, enable outputs. Now we're going, this is even simpler maths, because basically min_int, the value of the minute that we want, times 68, which we worked out as 68 steps per minute. And then it disables the outputs. Now in order to test this, I've written something very similar to what we had before. I've put it in the loop, it's another for loop. It starts at 0 because I finally got round to printing out the data sheet for the real-time clock. So I could check, and the minutes do go from 0 to 59. So this for loop will go integer I equals 0, while I is smaller or equal to 59, I plus equals 5, because we don't want to sit here and wait for 60 lots of movements. It'll hopefully move to each 5-minute point. Display minute, I, so it sends I off to display minute, and then wait for 3 seconds while we check whether it's in the right place. Right, but without further ado, let's upload that and see what happens. Okay, it's uploaded. The hour hand's found its doodah. Right, minute hand's found its thing. Now what hopefully should happen... it's been sent 5, so it's gone to 5. And it's been sent 10. You can see how useful these for loops are. Brilliant things. Right, I'll stop that now and we'll come back to it when it's reached the other end. It's getting there, and it's actually been fairly accurate. But like I said with regard to the hour stepper, these stepper motors seem to be sometimes a little bit sticky and need to run round several times, so you could just leave this going and then come back and see whether it does indeed point to the right bit. So it's not going to go to 59, it's going to, that's it, it's going to go back to 0. Now that's not a problem because, you know, obviously this is a quirky clock. So having hands going the wrong way whenever it's the start of a new minute, I don't think it matters. I'm very happy with that. It's nice having it slightly quirky. After all, the hour hand doesn't go all the way round and has to go back round. So I think we're happy. So the last thing to do is to get it to actually tell the time. So now we've finished testing everything, go back to the loop. We can delete or comment out that function and write one that's now going to read the real-time clock. Here's one I prepared earlier. Right, so this is loop again. This time we're creating a variable called now, and it's a data type called datetime, which can then hold all the information about the date and the time. Surprise, surprise. We're going to make that equal to the RTC object, so we're going to read the real-time clock for its now time. What is the time, date, and everything else now? Now we're going to call our function display minute, or the one we call display minute, and we're going to pass it now.minute. So that's lovely. It's extracted the minute part of that variable, the now variable. That's a value between 0 and 59. I know that because I looked at the instructions, as I think I mentioned earlier. Then we're going to call the display hour function and send it now 12 hour. That will extract the 12-hour version of the time from the now variable. And that will be a value between 1 and 12. That's why we didn't need that first bit on the original display hour function. Lovely. Then that's just going to go round and round and round, sending our two wonderful functions the correct time. We don't have to worry about having some sort of if system to only call these when the minutes change or the hours changed, because basically it'll send all the information through. If the stepper motor is in the right place, it'll ignore it anyway, so it doesn't matter. And then there's also this, which is wonderful. So again, you give it the now variable, but you can say is PM. You can ask it if it's AM or PM. Is PM. So if it's PM, it'll be high. If it's AM, it'll be low. Put that in an if statement, and then you can have something, perhaps even like a servo motor that could flip between AM and PM and let you know which one it is. So that's lovely. One thing to bear in mind is that when you read these now minute, now 12, now this, that and the other, you have to have created it in the same routine or function. It has to have read that. If you don't have that, like that for example, because it's commented out, it won't make any sense, and it'll either do nothing, or when you try and compile it, it'll warn you that it's missing some information. So just be aware of that. You can call that as many times as you want, wherever you want though. Lovely. Let's upload that and give it a go. So the time sponsored by my laptop says that it is 1:33. So it's uploaded, it's now calibrating. Did the minute first. I have no idea whether this is going to work or not. I haven't tried it. That's pretty good, isn't it? Is that going to go to 1? You can do it, you can do it. Yes! There you have it. Proof of concept. You've managed to create your very own Arduino powered stepper motor driven clock. Oh, I'm very pleased with that. So now that can just be left running. In fact, I can unplug that. Thank you for your hard work, laptop. Now every time that's plugged in, switched on and off, it'll show the time. I can prove that to you. Let's just switch that off. There we are. All power off, switch it on, and then it should go through the process. And the great thing is, hopefully you've learnt how to understand how you can turn an integer number into a display driven by a stepper motor or two. That means, of course, you can display anything you want. You could have a display like this to display barometric pressure or temperature or anything that you can imagine, air quality, because you can get so many amazing sensors these days, I2C sensors. Oh, the sky's the limit. That's why I find the Arduino and all the associated bits and pieces so thrillingly exciting. Because, as I said before, the sky is the limit. You can imagine something, I bet you can buy a sensor for it, and then you can get it to display it in so many different ways. Because with this clock as well, we could have added a servo motor and had it to indicate AM or PM. Well, I'll have to stop somewhere though. This could go on and on. Thank you very much for watching. I hope you found it enjoyable and informative. If people are interested, I could actually put all the Arduino files on my website so that you could download them. Let me know, and also if you're interested in getting hold of any of these bits, let me know. I think I've just received an order for an epizooscope, a luminescent epidioscope. I can't even remember what the word is. So that's very exciting, because hopefully the next video I can start showing you how to build one of them. Thanks again. Right, I switched this off at 7 minutes past 11 last night. It's now this morning and it's something past 8. Let's see what happens when I switch it on. Oh, will you look at that? What's the joy to behold?